I am passionate about solving big questions that are in uncharted territory, that have been neglected or not really addressed, often because of the lack of interdisciplinarity needed for problems at the intersection of physics, health and disease, and a changing environment and climate. Our goal is to stop the transmission of infectious diseases and develop multifaceted tools that tackle the path of transmission, really from one host to the other. From the point of view of the pathogen, there are extreme changes that the pathogen have to overcome to remain virulent, to remain infectious, once it hits the next host. Temperature, moisture level, the chemistry shift. How does it do that? Often to tackle these challenges of infectious diseases, we look at the current problems, but with old mental models or paradigms. What we try to do is develop completely new paradigms, and that involves very much physics, engineering, optics, coupled with algorithm development to process this information. For example, prior to our work, the conceptualization of transmission of respiratory disease was that we emit isolated droplets. It turns out that's not at all how the physics of that process takes place. What we emit is in fact a cloud. So the guidelines that have been in place for the 1 to 2 meter distance and masking, for example, were based on an outdated physical picture. Our work is now being incorporated in the guidelines. These are untapped, challenging questions. They require depth in a particular domain. They require breadth and curiosity to stretch to other domains and learn what's needed along the way to solve the question. We're looking for people that are excited to be on such a challenging journey, uncharted territory, to decipher these huge questions.